Hi friends, welcome back. Today we will see another video on computer vision. So today we have a case study on video processing and object detection with Faster RCNN and or we can say FRCNN with Resnet50 as base model, right? So before wasting time, let's get it started. But would request you to please do like, share and subscribe because we get highly motivated when we get the response from our viewer. So let's get started. So first we are using blue library, so PFI, NumPy, MaxNet, Matplotlib, Gluon CV, right? So first let's install the necessary library for the notebook. So pip install git. So basically this is a library for getting the YouTube in collab, right? And if you want to do it in your local system, so you can do it like that. Now pip install YouTube DL, so library to download videos from YouTube. So pip install glue on CV. So this is basically deep learning framework for quick experiment with pre-trained model, right? So once we install this, next we are installing the MaxNet. So this is basically backend on which glue on C is built on by Apache. Now a conda install C. So this is the conda command. Basically if we are using a Google Colab, so we do it, you can see that, to import all these patches right in the local system. Now importing libraries. So first open CV as CV2, so for image processing, then 5, then PFI, then NumPy as NP, Matplotlib, right, MaxNet as MX. So basically for matrix operations, Gluon CV. Now Gluon CV import model zoo data utils. Now plotting in Google Colab. So basically we use this patches, but if you are not using Google Colab, you can simply ignore it for this current notebook. Now these are some link that get pre-trained FCNN with base model Resnet50 trained on Pascal VOC dataset, right? That is Pascal Visual Object Classes. We are using Gluon CV library in this notebook for doing computer vision. It is great library for building production level code for deployment process. We are using model zoo model from Gluon CV. You can read more on this here. Now you can read more on Faster RCNN model and the ResNet model from the official paper. Now a short tutorial. So basically all these link, if you require, you can check them out. Now get the pre-trained Faster RCNN with the Resnet50 as base model v3 model from model zoo of Gluon CV. So we are using net equals to model zoo dot get model Faster RCNN Resnet50 version 1 VOC, right? So pre-trained equals to true. So basically we are specifying here the YouTube video link, so you can also take it any link if the required library is installed. Now pay5.new URL. So basically vpay5 is a pay5 object to convert the URL into a video to be accessed for this notebook. Okay, now this is the method to get best resolution irrespective of file format. So let us write a function that will take in a frame of video and perform object detection on it. The command code is for you to understand the pre-processing that is done before feeding into the model. However, we don't need the same as Gluon CV offers the same in the form of transform modules, but I'm keeping it to give you an understanding of what is happening in the backend, right? So creating the function. So here we are accepting the RGB frame. Final array equals to mx.nd.array RGB frame. So converting the array, converting the video frame into mxnet numpy array, right? Then x and img gluon cv.data transform persist rcnn transform test for final array. So transform the array of the model in shape. Now doing the class IDs and score bounding boxes, getting all these from netx. Now ax equals to util dot viz.plot vbox. So here create an access object with the information and respective classes, so on so forth. You will once you will call the function, we will get to know about it. Now let us write a function to play the original video file that we get from the YouTube URL, right? Now so we are playing original video, so cv2 dot video capture play dot url while true. So get frame, so basically this function will open a window and it will play the video there, right? Now defining, so let us write a function that will read each frame of the video and pass it to the function that we wrote earlier, that is this one, in order to do end-to-end object detection in video, right? So do video object detection, so cap cv2 video capture play url. So while true, that means it will keep going. Ret and frame equals to keep dot red, cap dot red, convert the image from bgr color with OpenCV uses to RGB color. So RGB frame equals to frame. So this is the way. Do face recognition here. So detect and label RGB frame. So we are calling detect and label our function, that is this one right here, and it will again open the window and will play the video. Now let us call both the function that we wrote, once one to see the frame of the original video and another to object detection. So play original video, so original video is just playing our video. So when I ran the when we ran the code, so it will capture frame from the original video like this is one frame, this is another frame, this is another frame, this is fourth frame, like that. Then we stopped it. Now when we call our actual function, that is do video object detection, which is detecting the object. So here you can see that in one frame, zoom into subsequent image to see the class and name clearly, right? So you can do it like that, zoom it out. So this is car, right? So similarly it is detecting all the recognizable car that we are using the base model. So you can see that all the car have been recognized, right? Then we stopped here. Thus we are able to do object detection using RCNN with Resnet50, and the model is predicting the respective classes with their equivalent confidence scores. So this is how you can play with it. This is how you can get the idea how object detection works. I hope it helped you a lot. If yes, please do like, share and subscribe. We will be meeting in the next video very soon. Our team is working on that. Till then, all the best. Have a good time.